Hello students, welcome back to your class 7 General Science digital class. Today we are going to study lesson number 6, Measurement of Physical Quantities. In this lesson, we are going to learn about physical quantities, scalar and vector quantities, mass and weight, standardized measurements, fundamental quantities, MKS and CGS system, International System of Units, importance of accurate measurement, and the causes of errors in measurement. We measure many things in our day-to-day life. When we buy vegetables and grains, we check the weight of the items. We measure liquids, density of various substances, the speed of vehicles, the length of cloth, etc. Nowadays, we are very familiar with checking the body temperature and the oxygen level in our body. So these quantities such as mass, weight, distance, speed, temperature, volume, etc. are called physical quantities. Thus, anything which is measurable is called a physical quantity. Without measurement, we cannot say the exact length, volume, area, etc. An arbitrary estimate gives us a wrong information about the dimensions of an object. For example, a carpenter measures the length and breadth of the wood before cutting it to make a door. So we see that measurement is an important part of our daily life. We use different instruments to measure different physical quantities. For example, we use the thermometer to measure the temperature. We use the tape to measure the length. We use a weighing scale to measure mass. You're also familiar with the temperature gun and the oximeter. Each and every measurement consists of two parts. One, a number or a numerical value, and a symbol or an alphabet that denotes the unit associated with it. For example, if the height of a student is 120 centimeters, then 120 is the numerical value or the magnitude, and centimeter is the unit of measurement. Thus, a numerical value and a unit are used to express the magnitude of a physical quantity. As physical quantities are different from each other, different units are used while measuring different quantities. Now let's see what's a scalar quantity. A quantity that can be completely expressed by its magnitude alone is called a scalar quantity. For example, only magnitude, that is, a value with a unit, is used to express quantities such as length, breadth, area, mass, etc. Thus, we say that the length of a tunnel is 2 kilometers. Vector quantity. The quantity that is expressed completely only when magnitude and direction are both given is called a vector quantity. Displacement, velocity, etc. are vector quantities. For example, a displacement of 20 kilometers towards the north, or the aeroplane is flying with a velocity of 500 kilometers per hour towards Mumbai. Now this is a list of scalar and vector quantities. Scalar quantities have magnitude but no direction. Now this is a list of scalar and vector quantities. Scalar quantities have magnitude but no direction, whereas vector quantities have both magnitude and direction. Mass. The amount of matter present in a substance is called mass. Matter has a natural tendency to resist a change in its state, which is called inertia. Mass is the qualitative measure of the inertia of an object. The larger the mass, the greater is the inertia. Now, mass is a scalar quantity. Mass is independent of its surroundings. It does not change from place to place anywhere in the world. Its units are gram and kilogram. When we use the two pans of a common balance in the shop, we compare the two masses. When you go to the vegetable vendor, he measures the mass of the vegetable by balancing the scales. Now let's see what is weight. The weighing scale is configured to display mass, but it does not actually measure mass. It measures force. The gravitational force that acts on the mass is called weight. The gravitational force by which the earth attracts an object towards its center is called the weight of the object. Weight is a vector quantity. Its unit is Newton. Weight is different at different places on the earth. That is, the weight of an object changes at different places on the earth, the poles or the equator. Weight at the poles will be maximum than at the equator, as the shape of the earth is not a perfect sphere. Our body has weight because of the gravitational force of the earth. The gravitational force on the moon is less than that on the earth. So our weight will be less on the moon, but our mass remains the same on the moon. Now, this is what you call a hand span, the distance between the small finger and the thumb. Now, if I tell you all to measure the length of a bench by means of the span of your hand, will each one of you obtain the same measure for the bench? No. Why? What could be the reason? Some of you may be having a long hand and some may be having a very small hand. So the measures will be different. So can you call this as a standard measure? When man felt the need to measure things, he started using the parts of his own body for the purpose. They used forearms, palms, and footstep to measure. Suppose the span of a hand is accepted as the unit for measuring length. With this unit, we can measure the length of a cloth. However, the lengths of the cloth measured by different people will come out to be different. Why this will be different? Yes, because the size of the arm of different people will be different. So, can we use the handspan as a standard unit for measuring length? No. That is why a handspan cannot be used for measuring length. The history of measurement systems in India begins in early Indus Valley civilization. A complex system of weights and measures was adopted by the Maurya Empire. On 1st October 1958, the Indian government adopted the International System of Units. In Egypt, in ancient times, the distance from a man's elbow to the tip of his middle finger was called a cubit. This measure would differ from person to person. Therefore, the cubit of the king was considered as standard. In olden times, an hourglass was used for measuring time. The need for standardized measurements. We need standard units for measurement to make our judgment more reliable and accurate. There should be uniformity in measurement. For the sake of uniformity, we need a common set of units of measurement, which are called standard units. We need standard units to minimize confusion or mistakes. Standardized units of measurement save everyone time and money and help ensure honesty in the marketplace. Thus, we have a unit which is acceptable by a majority of the people as a basic unit of measurement and is called the standard unit. The prevailing systems of measurement. The MKS system. In this system, distance or length is measured in meters, mass in kilograms, and time in seconds. In the SAGES system, length or distance is measured in centimeters, mass in grams, and time in second. Now let's try to complete this table. Here the physical quantity is given. You have to write the units in MKS and CGS system. Mass. The unit is kilogram in MKS system and in CGS system it is gram. For distance, meter, and in CGS system it is centimeter. Time. Seconds in MKS system and seconds in CGS system also. Now knowing this, let us try to find out the unit of speed. Speed is defined as the distance covered in unit time. So, what is the unit for distance? Meter, and time, seconds. So the unit for speed in MK system becomes meter per second. And here it will be centimeters per second. Now let's study about fundamental quantities. There are many physical quantities, but a majority of them are related to each other. We saw in the previous example that speed is the ratio of quantities, distance, and time. So it's enough to select a few out of the many quantities and standardize their units. Such quantities are called fundamental quantities and their units are called standard units. There are 7 fundamental quantities. All other physical quantities can be derived from the fundamental quantities. For example, let's take the case of area. Area is length into width. What is the unit of length? Meter. What is the unit of width? Meter again. So the symbol for this becomes meter squared. So same way we can derive the units of other quantities which are related to the fundamental quantities. So these are called derived quantities. So we see that all other physical quantities can be derived from the 7 fundamental quantities. So they are called as the derived quantities. The International System of Units, or the SI unit, abbreviated from the French Système International, is the modern form of the metric system. It is the only system of measurement with an official status in nearly every country in the world. The system allows for an unlimited number of additional units called derived units, which can always be represented as products of powers of the base units. Now this table gives you the 3 fundamental quantities and the name of the units and symbol. Length, the name of the unit is meter and the symbol is m. Mass is kilogram and kg is the symbol. Time, the unit is second and the symbol is s. The standards of fundamental quantities. As a standard of mass, a solid cylinder made of a platinum iridium, that is 90% platinum and 10% iridium, is kept in the International Bureau of Weights and Measures at Paris. This mass is called 1 kg. This was made in 1889. It is preserved under 3 glass covers at the International Bureau of Weights and Measures in Paris. Official accurate copies of this prototype are distributed around the world as national prototypes. 2 fine lines are engraved on the platinum iridium bar kept in the International Bureau of Weights and Measures at Paris. The distance between these 2 lines is accepted as the standard meter. Importance of accurate measurement. Is it necessary to make measurements accurately? Yes. How accurate a measurement must be depends on its purpose. Accordingly, an appropriate device has to be used for the measurement. For example, while measuring vegetables or grains, a difference in a few grams here and there does not make any difference. But the measurement of substances that are precious, of great importance, and are used in very small quantities is done meticulously and accurately. Now, with the advancement in science and technology, devices that measure very small magnitudes are available now. Let's take an example here. A photo finish occurs in a sporting race when multiple competitors cross the finishing line at nearly the same time. Here, the naked eye is not able to decide the result. So, what do we do? So, a photo or a video taken at the finish line may be used for more accurate result. Now, this is a digital gold weighing scale. Gold is a precious metal. Its rarity, beauty, and enigma have provided it with the status of a valuable commodity throughout the history of humanity. So gold has to be measured accurately because it is a very precious and costly item. Now let's see what are the major causes of errors in measurement. The first one, not using an appropriate device. And the second one, not using the device properly. At the grocery shop or the vegetable market, a proper balance or weights may not be used. Now, to prevent consumers from being cheated, a weights and measures subdivision functions as a part of the Food, Urban Supply and Consumer Protection Division of the government. The officers of this subdivision are expected to visit places from time to time and make sure that the weights and balances being used are proper or not. It's a binding by law to use standard weights and measures. With this, we come to the end of the lesson. Let's take a quick revision of what we studied. We studied about physical quantities, scalar and vector quantities, mass and weight, standardized measurements, fundamental quantities, MKS and CJS system, international system of units, importance of accurate measurement, and the causes of errors in measurement. Read the lesson carefully and understand the points discussed. Learn and write down the new words. Thank you and have a nice day.